Let's get started. So those who are making their way in, if you just want to come down and grab a seat at the front. So this, the title of this session is a bit provocative. It was done so fairly intentionally. I want you guys not to take away the fact that you should not be using SQL, if that makes sense. So I'm not saying get rid of SQL. You should never use it. In fact, quite the reverse. You'll see in the demo that we do today, there is a SQL backend. And I think most applications you'll ever build will have a SQL backend. That said, we have built some quite large applications with no SQL backend. We've used alternative storage, etc. The purpose of this session is really to get you guys to start to think about the cloud and the capabilities of the cloud. Because too often we see people deciding to go to the cloud and not doing it for the right reasons. Or they go to the cloud and then actually don't make use of the fact that they're in the cloud. So today's session really is about exploring. Basically, there's two patterns that we'll see in the demo, one for saving data and one for retrieving data. And you'll see how those can leverage off the fact that we're not using a SQL database, or at least we are, but it's right at the very back. It's used basically so that we've got a record, we've got a relational record of what's going on. But the clients are not, the client applications, and whether that application be a web interface or whether it be a true native application, you'll find that those are not directly interacting with the database. For those who don't know me, my name's Nick Randolph. I run a development company called Built to Roam, specializing in mobile app development. And you might be saying, okay, well, what does he know about Azure? Well, the thing is, building mobile apps, you spend a lot of time building services to go with those, because 9 times out of 10, even if an organization has an existing web asset or they've got an existing back end, chances are they need to put a new front end so that you can access it for the mobile apps. It may be a new set of web services, or it may be just adapting some of their existing ones so that you can pull and cache and synchronize data. Because there's a completely different mentality between web developers, and how many of you in the room are web developers here? Yeah, don't be afraid to admit it. Okay, I won't pick on you. There's nothing wrong with being a web developer, but as we're seeing with various frameworks like Angular and React and a lot of those sort of SPA style frameworks, gone are the days where we're building one page and then we transition to another page, right? It's all about building one app, one page that kind of looks like an app. Oh yeah, so we should be caching data and we should be syncing data and we should be doing some offline support. Hey, we'll convert you guys into being app developers in the end, okay? And then you'll build with rich frameworks like Xamarin and UWP, and you go, oh my God, why did I ever do JavaScript? And then you'll come work for me. Right, okay, let's get started. So, how not to do the web? So, we all agree that the cloud's a good thing, right? Well, actually, I was talking to somebody at lunchtime who basically, he was a Microsoftie, and he's still getting people rocking up to him and going, yeah, the cloud will never take off. It's like, I'm sorry, but the cloud's already taken off, okay? I can't possibly fathom starting a project that doesn't in some way use the cloud, okay? It just doesn't happen these days. There are some scenarios where data sovereignty is really important, but even those, now we've got an Australian data center, you could argue that most of those can go in the cloud in some way, shape, or form. So, step one, we agree that the cloud's a good thing. But then we put stuff in the cloud that is basically a traditional architecture. So we just handball things from our IT Pro on-premise into the cloud. And we go, hey, that's good. I've learned something. I know now how to deploy stuff to the cloud. But then we get to this point where we're not really impressed about how fast it is. In fact, things have probably slowed down, right? Because we're doing cloud for everything, and there's this big added latency for my traditional architecture because it was never designed to run in the cloud. Okay, I've optimized it pretty well to run on my on-premise stuff, and putting it in the cloud hasn't made it any faster. So we think, oh well, hang on, maybe I chose the wrong cloud provider. So you go, okay, well let's switch cloud providers, and pretty much you get to the point of the opinion where you think the cloud is slow and expensive. And I might add, it can be very expensive if you get the wrong architecture, okay? If you haven't already seen Troy Hunt's presentation, I would highly recommend watching his session. He goes into a lot of details about how you can run things in the cloud at super high scale, but on a shoestring budget. So the cloud is definitely not expensive, definitely not slow, but if you do it the wrong way, it can be both. So people then go back to self-hosting and you go, it's quicker for me to stand up an instance. And there's a big mentality about, okay, well, I can build it and do it myself quicker, and at least I've got control over what's going on. Whereas in the cloud, I feel like it's not in control. So how do we get around that? Well, first thing is stop what you're currently doing, right? There's no point in taking what you're currently doing and just throwing it into the cloud. Actually, there are some benefits of doing that. So things like backup and recovery, you can scale out much quicker. There are some benefits of moving to the cloud, even if you stick with the traditional architecture. But if you really want to take advantage of it, take a step back. Stop what you're currently doing. Next step is choices. Okay, the cloud, particularly now, has got a ton of choices. Okay. Back when I first started working with Azure, there was kind of like one way of doing things. There was like these web roles and these worker roles, and that was pretty much it. Oh yeah, you had some storage stuff, but you were kind of constrained as to what you could do. Now, you look at a cloud project and you can go, okay, well, storage, I could use SQL, I could use blob storage, I could use table storage, I could use document DB. The list kind of goes on and on and on. And in some cases, you don't use any of those, you use a queue. And the only persistence you've got is what's currently in the queue, right? And once you've dealt with the queue, there's nothing more to store. There's even apps like that, right? So there's a whole choice of what you can actually make use of. So where do we go from there? Well, we go back to principles, right? We actually architect the thing properly. And historically, we've really looked at simplifying architecture because that generally ends up being a good idea. So you end up with like 3 tiers or n tiers or whatever. And that looks pretty nice. It looks great when you're standing in front of a group of people and you say, hey, this is a really nice, simple architecture, it scales, blah, blah, blah. The problem with cloud architectures is they look a mess, right? I mean, there's just not enough space on the page to fill everything. By the time you've got blob storage, you've got web jobs, you've got queues, and you've got messages going left, right, and center. But that's what you need to do in order to get it to be architected correctly and in a cost-effective manner and be performant, right? There is no silver bullet or golden bullet. You need to architect it based on the solution you're building, right? There's a couple of patterns, and when you're building apps again and again and again, and particularly from our space where we're building predominantly mobile apps, the back-end infrastructure kind of looks fairly similar. So we do end up with a SQL back-end. We do end up with web jobs, so there's somewhere to do some processing. We do end up with some form of a web API presence, right? And you could argue whether that's full framework or ASP.NET Core, but those are kind of smaller decisions along the way, right? The overall pattern kind of feels the same. But you draw that on a page, and it still looks a bit of a mess, because you do have things going back and forward, and it's not this sort of linear architecture that we're used to. The other really nice thing about the cloud is it allows you to do these other steps really, really effectively, right? So build, test, deploy, analyze. There's a plethora of tools out there that allow you to do that in a really effective way, okay? So the architecture is the fundamentals. Once you then go into build, test, make use of the tools that are available in the cloud, okay? How many people here are using some form of automation for their build and deployment, okay? Okay, I said some form. How many people still do any form of manual deployments? So you have to sit there and do it. Okay, we have a rule in our company. We don't do any manual deployments, okay? The only thing that we do is when we're publishing things from test into prod, we hit one button and it switches things from being test instance or test slots, as you talked about, into production. That's it. Everything else comes from our source code. It gets built on demand. Sometimes it's continuous delivery into a test environment. Most of the times, even the publishing out to a test is a manually invoked step, but the whole process is fully automated. Okay, so I'd encourage you to make use of the tools, and the tools are there. It's relatively easy to configure. Rinse and repeat. Okay, you want to make sure you do this again and again and again and again and again. Okay, because you get pretty good at it once you do it a number of times. The other thing about rinse and repeat is that you refine the architecture all the time. And one of the things about the cloud is because there are a variety of tools to actually get the same job done, don't be afraid of saying, hey, I'm not sure that this is the right option anymore. I think that there's a better one. Because, well, Microsoft keeps on releasing new tools and new tools and new tools and new technologies. And so what was correct 2 years ago, maybe even 1 year ago, isn't necessarily the best tool for the job today. Okay, so, and might not be the cheapest option today either. And so, over time, you'll find that your cloud solution evolves, okay? And the trick there is that you need to plan for that upfront, because you need to plan that the different components are separated enough that if you have to pull one out and replace it with another, you need to be able to say, okay, well, that's, it shouldn't be a 3-month job. It should be, okay, let's spin up a test instance, let's see if it works, and now let's work how we migrate stuff forward into that new environment. Okay, so the goal is really faster solution, lower cost, higher volume, i.e. winning, okay? That's what it's all about. So let's just do a bit of a recap, okay? Two-tier architecture, I have a database, I have an app, bam, I have a database app. How many people, we must have all built one of those at some stage in our lives, right? I mean, it's the file new project kind of the world. In fact, yeah, we've been there, done that. And particularly in mobile land, it's becoming increasingly easy to do that just on a mobile device, right? There's new things like SQLite and the wrappers, particularly with any framework core that wrap around that, basically means that you can build a mobile database app on the device just by spinning it up. It'll take you less than a day to actually get something up and running. Now, whether you want to do that or not is another question. So we move forward a little bit, and then we talk three-tier architecture. And we do this for a whole bunch of reasons. It gives us separation of context. It gives us the ability to wrap security. It gives us a ton of options around logging and caching. And it's just generally deemed to be a good principle rather than having an app that talks directly to our database. Do you know the number of times on forums that I've seen people whinging that UWP does not have an ADO.NET provider? I mean, seriously, at this day and age, I mean, that was cool like 10 years ago to have my app talk directly to the database. It's not cool today. And I can't imagine doing anything in the cloud where I'd want direct database access for my rich application or my website, right? You'd want it always proxied by some level of services. And again, there's a bunch of options, right? So if you're building, ASP.NET Core, you're probably going to have to write your own web API that's going to do sort of basic CRUD operations. But that's where there's things like mobile services and Azure App Services where you can, out of the box, you can get CRUD providers for all of that. So you can literally have, spin up an instance of mobile services and it will expose out tables within your database as CRUD operations. So, post operations, the equivalent HTTP verbs for the CRUD operations, so post, delete, etc. And all of a sudden your mobile app can start consuming those, right? And so again, it's a really easy thing to spin up. But again, you have to be in the cloud to take advantage of that. Okay, so we're on to N-tier architecture, and this is where we really design it for scaling out of intermediate components. But this is where I get to the point of this presentation. It's really, really difficult to scale up a database, or scale out a database, right? Generally, you tend to scale up more than you do out, and particularly with SQL Azure, there are now some really, really, really expensive options around scaling up. Like I think the most expensive instance now is 16 grand a month. That's a pretty big database, but you also need to be earning a ton of revenue out of whatever you're doing to justify 16 grand a month in terms of just running your database. So, I now get on to the next point, and this is where you can start to see the fact that I've been a mobile developer for so long. Offline is the golden bullet, right? Because if you can build your app to work offline, you don't care when connectivity is not available, okay? So the trick here is to think about, okay, well, how can I build my app so that I can download stuff for offline access, okay? Because if I can do that, then pretty much I can read and write locally, and then potentially synchronize when I'm online. And so this solves connectivity issues. And so connectivity issue manifests itself in a number of ways within a mobile app. First of all, when a user hits the save button, they don't have to sit there waiting. The number of apps that I've seen that just are so slow because they rely on being connected, okay? It also solves, if you actually think about this up front, it also solves bandwidth, okay? So, if you're going in and out of network coverage, or if you're on a very limited data plan, right? If you can actually start to cache some of that locally and actually think of that, how you're going to do that up front, then obviously that's a better user experience. It also reduces load on the back end, right? Because if you think about a way particularly a consumer app operates, it typically has peaks and troughs through the day. So for example, if you've got a food ordering app, right? Typically that will have peaks around the time when people like to eat, and then it'll have troughs when they're not, right? And so it doesn't make sense that every time the app loads to go and download the menu or download items that don't change that frequently, just because you haven't thought of enough ahead in advance to think, okay, well, I should be caching a lot of this data, okay? Or at least I should have it available on a CDN endpoint so that it comes down really quickly and it doesn't have load on my back-end server. So if you start to think about how you can at least architect your client app to be offline aware or to cache data, you reduce the load on the back end. Okay, but whilst offline is the golden bullet, it massively increases complexity. I'm yet to talk to somebody who's done any form of sync, now whether that be invalidating caches on the client side, or actually true sync where they do incremental changes on the client and the server and they actually have bidirectional synchronization. Yet to talk to somebody who's ever done that successfully first time, okay? There are always problems associated with it, and they never go away. I don't care how much you play around with it, somewhere down the line, somebody will go, this isn't syncing properly, and you'll go, oh, because I've seen that before. And yeah, again, it's a hard problem to solve, and chances are that, it'll be something to do with change tracking, okay? Because you need change tracking on the client side, and you need it on the server side. And what do you do when there's a conflict, okay? Do you let the server deal with it? Unless you've got a gremlin that's sitting in your server that knows what to do with that conflict, no. Okay, so then you need to synchronize that conflict back out to the client. Okay, and then you're reliant on the person who's actually using the app to make a decision and presenting a user experience so they can make that decision. Okay, so that's, again, in itself is not particularly trivial. And it can actually increase load during synchronization. You know, the worst thing that can happen is everyone comes back to the office at the end of the day or whatever, and you have a single point where everyone decides that they're going to synchronize at the same time. They might all get to the office in the same time in the morning, in which case that might be the crucial point, right? But you can actually have peak loads where people tend to synchronize. This one is actually easier to manage than the other one in terms of load, because generally, if you take a look at the pattern that evolves over time, you can actually plan for that, and you can actually have scale up and scale down periods that allow you to make sure that you can manage that load. Okay, so into the cloud, there's many, many different components and many, many different ways to build solutions. So the rest of the session is going to cover off two scenarios, and there will be quite a bit of code. And essentially these cover data processing and data retrieval. I do apologize, the slides that probably will publish online, I've actually got these the other way around. It doesn't really make too much difference. I'm going in this order because the demo makes more sense in this direction. Traditionally, the data processing, typically your app does something, okay? And you want to save that to the back end. And so what you do is that basically you'd send the client app, be it a website or an app, you send a request to the service tier. The service tier goes and communicates to the database and say, hey, this record needs to update. And the database goes, yeah, that's fine, okay. But I've got this whole bunch of other stuff I'm doing right now. I'm not going to respond for 30 seconds or whatever. It takes a bit of time. And so while your client is happy to do that, it's not a great experience for the user because they're sitting there and there's probably this spinny cursor in the middle of the screen. A better option would basically for the client to basically say, hey, I got this request and there's this job that needs doing, sends it off to the server or the service, and the service goes, yep, that's fine, I've got it, put it on the queue, and responds back to the client and says, yeah, look, I've got it, I'll tell you when it's done. And the client goes off, does its thing, and this is particularly true on mobile apps, right? I can't imagine the number of times that I've gone, yep, okay, I want to send that or save that, and the worst for this is that we have a parking meter service near our, where we work, and the number of times I've gone into their app, hit save or hit pay or whatever it is at the end, and then I've immediately turned my phone off, pull my phone out 20 minutes later, and it's gone, service request has failed. It's like, that probably meant I didn't pay for parking. Luckily, most times I don't get a parking ticket. But you get the idea, is the sense that if they'd actually queued that request instead of actually waiting for the server to actually respond and make sure it's gone through, I wouldn't be in the situation where my payment actually didn't succeed. Now, the trick here is that you need a mechanism whereby you can notify the client that something's actually succeeded or failed, okay? And that's where push notifications comes in. And granted, this is a very app-specific scenario, but there's things like webhooks and other things that you can do on the client side for web applications that can leverage that as well. So that's data processing. Data retrieval, this is particularly, and this isn't going to solve data retrieval for every scenario because granted, as things change, if things are changing very dynamically on the server side, you can't rely on a lot of cache data. But in this scenario, we're going to say, okay, a lot of the data coming from the server can be pre-generated and doesn't change that often. And so what we're going to do is we're basically going to use a web job to basically generate static files that are going to go in blob storage. And in actual fact, once you push a static file in blob storage, you route it through the CDN, and you're down to like sub 10 milliseconds in terms of response times. It's insanely quick, okay? And actually, when we get onto this, we'll talk about how you can actually leverage that concept even with data that progressively changes with time. All right, so let's jump into it. I'll go into a little bit more detail about the scenario. So traditionally, a client sends the update to the request to the server. The service processes the update, does whatever it needs to do, sends the update to the database. Database succeeds or fails, and then the service responds back to the client, okay? Where this falls down is, again, connectivity, okay? So if you're not online, you've got no data. Yes. If the service isn't available, okay, you've got no data. You've got no ability to actually save that record. Database is not available, okay? Again, you've got no data. You've got no ability to save that data, right? And so those three alone basically means that that request you fired off is gone, right? It's died, it's failed, it's going to come back as a failure, okay? The more concerning one is an update where the client says, okay, HTTP send, okay, and then you turn your phone off, okay? Did that ever come back to me? I mean, or what happens if the network dropped out? Okay, the best that you're going to get is a HTTP fail, basically saying, hey, that didn't go through. Okay, but that doesn't say whether it actually did go through or not. All it says is I didn't get a valid response, okay? Now, particularly if you don't think about this, okay, you then hit save again, because it didn't go through the first time, and now you've got two requests going through, okay? And I guarantee the number of apps that are designed to be connected that don't think about idempotency, so the ability to send the request multiple times, means that you get double up of records, okay? So that's a very, very common problem, particularly in mobile space. And then we talk about performance, okay? So now you're reliant on the request to the server being performant, okay? And for you to get a response back within 10, 20, 30 seconds. Now, that may not be the case. And as we'll see in the demo, the scenario there could potentially take up to, like, it could take 5 minutes to run, okay? In which case, the user's not going to sit there for 5 minutes with a little dial on the screen, you know, waiting and waiting and waiting, okay? They want instant gratification. They want to be told that whatever they did has gone through, okay? And so that's obviously the end user experience. They have to remain on the page or the app in order to get that response back. One of the funniest things I've ever seen in an app was basically the user hits save and the dial comes up for a second, then goes away, and they think, okay, cool, and on to the next thing in the app. And they're browsing around, and all of a sudden they get this pop-up that says done. And it's just like, done what? I didn't do anything. I did something about 5 minutes ago, but what's this message? And so what had happened is basically they were handling the sending and receiving at an application level, and they were just assuming that the user was still on the same page. So that was an entertaining one. We kept on getting these done messages that had no idea where they came from. Okay, so in terms of the cloud, the process looks similar. The client still processes or prepares an update request. And I've used that terminology to basically say they prepare the update request because they basically want to make sure that if they have to send it multiple times, they can. And you need to think about how you're going to track that and whether you're going to have a GUID that uniquely identifies that so that the service doesn't handle it multiple times. Send the update request to the service when it's available. Okay, so now you're thinking about, okay, triggering behavior when you go on and offline, okay? Or you might try to send the request irrespective of whether the device thinks you're connected or not. And that seems a bit of a weird thing to do, but in actual fact, the cost associated with checking to see if you've got a network, that's actually relatively straightforward. Your device is pretty much guaranteed to tell you whether you've got a network or not. What it's not going to tell you is whether your service is available or not, okay? And the reality is, unless you've got a mechanism for saying, hey, guaranteed my service is 100% available, which isn't really possible, you might as well just send the request off, and if it bounces back and says, you know, 404, it's not found, then chances are you've got a connectivity problem, okay? So that can actually be quicker than actually having to do a check to see whether you're connected first before you attempt to send it, okay? So check to see whether it's available, and then if it's not available, then you want to do some monitoring of network behavior, right? Because chances are if your network doesn't change, then your connectivity to the server doesn't change. Unless your service is bounced for some reason, in which case you might want to try it after a certain period of time. But the point is that from the client side, you can resend that request until you get a successful response back from the service. Service queues the update request and basically responds directly back to the client to basically say, yep, okay, I've got it. If you need a tracking number, you can provide a tracking number back at that stage. I would suggest that if you're going to use some sort of tracking number behavior, that it's actually the client that generates it as a GUID initially. sends it to the server, and then the server bounces back the same ID, because that way you're guaranteed that the client always knows that it's the same request that they originally sent. Sometime in the future, a web job picks up the request, and we'll see today that we're actually using a web job that's queued, or that essentially wakes up when it's got an item queued. I use the term web job here. You can actually use an Azure function for this. I was talking to Paul from the functions team yesterday, and sort of functions build on top of web jobs, but there is a bit of an overlap, particularly in terms of building things that actually are going to respond to queue events. So you can do it as either. We went down the path of using web jobs just because it sits nicely within an Azure service. Okay, and once the web job is done processing, we need that mechanism to send back to the client. So, and that's where we use push notifications. And particularly using the notification hub, you'll see here that it's really easy to make sure that we're only notifying clients that have actually sent a request. And you'll see why that's important shortly. Okay, and then the client obviously needs to update and notify the user that the update is complete. Now, one of the really nice things about push notifications on most platforms is that whilst they would come in as a push toast, so typically a notification that comes into the notification hub or the action center or whatever your platform of choice calls it, if your app is already running, you can actually intercept that before the user even sees it. So again, different platforms behave slightly differently. Android pretty much intercepts every single request, and then it's up to you whether you bubble it to the user. Windows basically handles it optionally, so you actually, if your app's running, you can basically say, hey, cancel the toast before it goes to the user, because I've already handled it within the app. So each platform is just slightly different as to how they handle that. But essentially the process there is that the user will get some form of notification. Ideally, if they're not in the app, they'll get notified in their sort of notification center, and they know that their update's successfully gone through. Now, I guess one thing you would need to be careful there is bombarding the user. So if they're doing a lot of changes in the app, if you're allowing all of those notifications going through straight through to their notification center, they will get bombarded. So again, you want to think about how you make use of the platform-specific things. So like most platforms now support an ability to basically put a tracking ID or some form of identifier there, so that the user will only ever have one notification with that ID at any given time. So you can sort of batch them in that kind of way. Okay. So the advantages here is, firstly, we're queuing things when we're offline on the client side, so we don't need to be online when we generate that request, which makes for a nice user experience, because I mean, I can use that save button whenever, and I'm not responsible for making sure that it's available. The flip side of this coin is that, and again, this comes back down to talking about synchronization. We've had so many scenarios where people go, the change hasn't gone through to the back end. And so typically what the scenario here is that the client will go into the app, do some changes, and then for whatever reason they won't be online and the update won't have gone through successfully. And then they leave the app and never go back into the app. And then 3 days later they go back into the app and it's like, my request never made it to the server. And it's sort of like, yeah, because you weren't in the app when you were online again. So you need to start to think about, okay, well, what platform behaviors can we invoke to basically get those cached requests sent, okay? I didn't say building things was going to be simple. I just said that, we're aiming for an optimal user experience. Okay, we do the updates, because we're queuing them with an ID on the client side, they're relatively idempotent. Of course, that depends on your service and how your service handles them still. And we've got notifications when it completes. From a user experience, it's really good because we've got virtually no blocking experience. You can go even further and start to queue things properly on the client side. So you literally dissociate a queue on the client side with the user experience, but that's getting over and above what you really need to do. Let's jump in and do some demos. So I'll jump across to Visual Studio and let me just run up this sample app. So this sample app is designed to look a little bit like the Windows Mail client, and so you'll see the theme from that come along. What the purpose of the app is basically to allow you to basically do persistent filters across your email, and by that I mean one of the scenarios we ran into is that we had to go digging for basically every email that correlated to a particular project. And it got me thinking that there must be a better way of doing this and managing these emails. hence this sample was born. So the idea here is that you have your email, you sign in with your email account, you create a notion of a project, which basically allows you to define one or more filters. And don't worry, that's 404 is supposed to be there. Lets you define filters that are associated with that project, and over time, it will basically pull in the individual emails that are associated with that project based on those filter conditions. So let me actually get started with the app. So the first thing we'll do is we'll sign in. And so I didn't have to enter any email credentials because what it's done, that flicker where it lost focus on the app and went up to the web, is actually Azure AD's sign-in process where you redirect and it redirects back. It's probably one of the most secure ways that you can sign into your apps. If you're using ADEL library, you're not that secure, particularly if you're doing it on iOS and Android, okay? The reason being is that they use an embedded web view. Windows is slightly more secure because it uses the web authentication broker, or whatever it's now called on UWP. But essentially, you're still hosting web content within your app. If you want to be really secure, you should actually redirect out to the external browser on a device so the user actually knows that they're going to a secure location that's owned by the trusted provider, in this case, Azure. And so if I hadn't been signed in, it would have actually prompted me for my Azure credentials, but I have 2FA enabled, so I'm not going to actually bother doing that right now. So this is my email box. I can basically provide search criteria, so let me put that into the search, and I hit search. It's going to come back with one email. Cool. I'm going to go save that as a project. Call it demo 1. Boom, and it's done nothing, okay, because right now we haven't actually got it to do anything. So that's the purpose of the demo. We're going to actually go and save that project, and the project's going to appear off to the left-hand side. Now, the thing about these projects is that they don't really, like the emails in those projects, once they've been received, it's not like they're going to change that frequently, right? So I might get more emails on the same project, but the existing emails are basically the same, right? So any search that covers up to the present, basically those search results aren't going to change for a given set of filters, right? So the back end of this is basically going to take that search filters, it's going to apply it over the current set of emails, and it's actually going to take a cached copy of those emails, right? And so the point of that, though, is that I might have 5 years worth of email, right, on a particular project that matches for certain criteria, right? So to go back over that quantity of email and make sure that it exactly matches the search criteria isn't a half a second operation. It's probably like a 30-second or a minute operation in the cloud. And I don't want the user to have to sit there. So as part of doing this, we'll step through the process of actually saving the project, and then we'll talk about the ramifications of how we build up that email, and we do it in a way that's actually not going to inhibit the user. So let's actually drop back to my app. And the first thing we need to do is actually implement or start to look at the implementation of the saving of the project. So here we are in my account view controller. So you'll notice that the structure of my application is very much, I have pages that are associated with a current view model. And for those who've done work in the app space, that's a fairly common pattern. Actually, while we're talking about architectures and patterns, I'm using most of the latest, greatest tools. So this is Visual Studio 2017. You'll notice that I've got a client folder and a server folder, and then I've got these entities at the bottom. And so behind the scenes, I'm using Entity Framework Core. And one of the really nice things here is because that's now compatible with both the client stuff that I'm doing and the server side I'm doing, it means that all my entity models, including all of the attributions and stuff that you need to get the entity framework to work, can actually be shared across the client and server. So that's that entity portable class library. It is, for those who are geeks and want to geek out on this, it's all .NET standard. So I've made that migration already. So it can be readily shared across those. On the server side, we've got a whole bunch of controllers. This is an ASP.NET Core, new project structure. It's all controller-based. And we've also got it generating Swagger, right? And the nice thing as we move forward is you'll see that I'll actually use AutoRest to generate the client libraries to actually do the HTTP requests. So again, I'm not there sitting writing HTTP requests, I'm actually using some prepackaged code to do that. And that's the purpose of this, I don't know whether you can see at the top there, this client library is just my generated code for connecting through to my services, right? So I don't touch any code in there, it's all generated. The core library is where all of the logic for my view models is held. The UWP project is obviously the front end, all of the visuals, etc. And I think that's it from a project perspective. Oh, no, on the server side, I've also got a core library, which is again where all my services and things like that live. And I've got this web job that we'll come to in a minute, but is really responsible for doing that saving of the project and then notifying the user back when it's done. So let's get started. This is my create project method. So if I put a breakpoint there, let's just run this just for just show that it does actually fit there. One of the things you'll notice is that all three start up when I actually run things, because I've got multiple projects to start up, which is very convenient. Okay, so I'm just signing in. I'm not going to bother putting a search criteria in there, and I'm just going to hit save project as soon as I can. And I'll hit create. Okay, and now we're dropping into our code. Okay, so this is basically the entry point. There is nothing really above that. It's just an event handler that basically routes into here. You'll notice that I've got a using statement there. I've got a nice little helper thing that generates or that data binds to the loading indicator on the page. And essentially, as I fall out of this using statement, it just guarantees that that loading indicator goes away, even if it fails. So I'm going to grab this little chunk of code that I've pre-created and drop that in there. All it's doing is literally creating a project entity, it's assigning the title, and it's applying the search filter. Now, I've omitted the other the other filter options here. I could go ahead and provide much more than that on this filter object, but for the time being, I'm just going to do the search text there. And then the part that we then need to implement is this ability to actually save the project itself, right? So let me just uncomment this code. And you'll find that this method doesn't actually exist. Now, on the client side, I've kind of got a service model that basically abstracts me from, or at least allows me to reuse services across the different view models. So when it says Mailmate services, this is actually the client side. Okay, so the service that sits in the client, and it's going to complain and say this method doesn't exist. Ooh. Let's drop out of full screen mode. Let me try that again. So it says create method in my interface, and we'll go ahead and do that. And that looking pretty correct. The only difference is that, of course, I haven't actually implemented that. So I will come up to my the implementation in a minute. Before I can actually go ahead and implement it, I actually need to think about what this is going to do. Okay, so I've created a project. I'm about to send it off to the server side. Before I can do that, that endpoint needs to exist. Okay, so let's just check to see whether that endpoints exist. So I'm going to be doing, it's going to be called project controller, okay, because my controllers are named by the entity types. And it's going to be a post operation because I'm creating a new item, right? Okay, so now it's whinging. So I haven't actually implemented it. Let me go ahead and do that. Visual Studio doesn't like it when you code and build at the same time. Just saying. Let's try that again. Okay. So the reason I wanted to run this up is because if I go to my website, which is just loading now, I love the fact that the entry point is pointing to a control that doesn't even exist anymore. And I go to Swagger. This provides me a nice GUI kind of interface to actually tell me what services are available on my endpoint. Now, in actual fact, this is actually coming from this JSON file. So if I just go to here, it's a JSON file that basically is a service descriptor for my services. This is all automatically generated. I have not gone in and typed a single word of this. and this UI basically hosts on top of that to basically show me. And you'll notice here that there is a get operation on project, but there's no put operation or post operation. So that's the first thing that we're going to need to do on the server side. So let me jump over to the project controller side. And it was down to the bottom here. And I'll run it back up again because one of the important things I need to show you is actually how do we go about generating that code. And while it's loading, I'm going to grab this because it's a snippet of code that I did have pre-prepared until my machine decided to restart just before I got on stage. So let me just come into here and of course it's not actually going to let me. So you'll notice that we've got these as, they're remmed out at the moment, but we actually keep them as pre-execution or pre-build events. The reason being is that quite often, particularly when we're in debug mode, we'll actually or generate the stuff as we're building things. Just that way, when we're changing stuff on the controller side, we're always updating the client libraries and we know whether they're breaking it or. So let me just find the right path here. So if you've worked with AutoRest before, you'll notice that this is it's just a call to AutoRest. And so what we're doing here is we're basically saying we're pointing AutoRest, which is just a tool you can download. We're pointing it at the Swagger endpoint, and we're saying, hey, generate me a bunch of classes on the client side that can wrap calling off to that endpoint. So let me just run it up again. I freaked out once because I went into the command line and actually started running AutoRest and it was coming back. I couldn't find the Swagger. And then I realized I was doing a local host one. I didn't have my solution running, which doesn't actually help. So while it's generating the client side, we'll notice if I go to Swagger now, we should actually see the post operation there. So there it's just appeared under the project controller, and that said that it's generated okay. Now, unfortunately, we made some changes to the sample that actually uses one of our tools internally, and of course, now when I regenerate everything, it actually comes up with that it can't find certain classes because I need to import them each time. So if I now build this, it's going to throw a couple of little build errors that are quite easy for me to fix. And so these are referencing classes that we already have, so I'll just step through those. All right, and we should be building again. Excellent. Okay, so with that done, we can now go to back to our services, and we should be able to implement this out. Just try that again into the right spot. All right. And you'll notice here that I haven't actually, this is the API method, right, that we've literally just imported, right? So it's very nice. It's all strongly typed. It basically recognizes that the entity I'm passing in is a project object, okay, the shared entities between client and server. So I don't really need to do any coding beyond that. Obviously, in a real world, I put try catches and some failover, etc., in there to make it nice. Of course, we haven't actually implemented the post method, so we've created a stub there, but let me just go and fill that out so that it actually does something. And again, this is relatively simple code. It doesn't have any sort of resilience in it at all. Here, all we're doing is we're going to create a project, and I need to associate it with my account. Now, I won't get into the intricacies of, but basically when I sign into this app, in the back end, it'll create an account in Azure for us, and that's what this active account does. It basically uses the current HTTP context, goes and looks at the claims and identity of the user that signed in, and it basically goes off to the database using our DB context to basically say, hey, if this user doesn't have an account already, go and generate one for it, and if it does already have one, then return that account. And I'm using that to basically provide the linkage between the project I'm creating and the account. So that's this account project object that was basically saving to the database. So that's pretty much the post operation. And so we can basically run that up. And with a bit of luck, if I've done everything right, we should be able to put a breakpoint there. And we should be able to now save our project. So that's me signing in. And we'll go ahead and call this demo 3. Okay, so this is our client-side code, so I can let that run now. And it's now hit our server-side code. And again, I'll let that run. And what we should see is that demo 3 appears, okay? Now, I won't click on it because we don't have any emails. We're not actually doing anything in the server side other than actually creating a record for that project, which is now the next problem, right? Because when we create our project, the first thing we want it to do is we want it to run the filters over my email and generate or pre-populate the database with all of these emails that match those criteria. Now, I'm not going to do that in that post operation because that could take 5 minutes to run. So I need to think of a better way of doing that, which comes back to what we were talking about, which is, okay, well, how can I re-architect this post controller to provide a response back to the user immediately, but actually go off and put things onto a queue so that we can process it later? So let me just drag over my queue code, and what you'll see here is that, oh, I need to keep the account code there. We're doing a couple of things here. The first two is in addition to retrieving actually I don't even need the account because I actually pull out the account ID. So the UPN is actually the principal name, which actually correlates just to my email address. We pull that out. We pull out my current access token. The reason being is if I pass this off to my web job and say, hey, go and do stuff, and it goes, I know who you are because you've told me your UPN or your email address, that doesn't help me. I can't access your email because you haven't given me any authority to do so, right? So by passing off the access token to the web job, that gives it some credentials to actually go and do some stuff on my behalf, okay? You do need to be aware that this is very short-lived. So the access token, if the web job doesn't pick it up within the 2-hour block for the access token, it's going to fail. But that's probably security by design, right? It's essentially, I don't want to give anyone a long-lived access token, particularly if they're doing stuff on my behalf, okay? But essentially, we're simply just queuing that operation as a entity, right? So we're basically passing this new project queue message. So it's got my account ID, access token, and the project, okay? So it's got all the bits it needs in order to go and create that. And the reason why it needs, obviously, the account is also so that it knows who to notify on the way back out. So go ahead and queue that. And then the next thing we're going to need to do is, that's all very good, and I can go and generate stuff on the queue, but we need something that's going to process it. Okay, and that's where my web job comes in. So I have got a web job, and you can configure web jobs to run in a variety of different configurations. There's ones that always run. You can have them time or trigger based. In this case, my function, or my web job, is triggered based on an entry to the queue. And you can see here that the name of this queue correlates with the name that I use of the queue down here, that I obviously want to make sure they're talking to the same queue. And you might be thinking, okay, but hang on, just the name's not enough. Surely they must be based on some sort of account principle and stuff like that. Yes, behind the scenes, I have a storage account, and within there you have that's where your queues, multiple queues can actually sit. So within your storage account, which both the web job and the web application are using the same storage account, within that you can create a number of different queues to handle different message types, etc. And that's what we're doing. So this is going to process the message on the queue. The first thing we're going to do is, well, The comment here actually says dequeue the message, but that actually happens for us, okay? So the message that comes into this method is already the dequeued message. Now, a couple of things. If for whatever reason your function never completes, okay, so for example, you stop debugging or whatever, the message will go back on the queue after a certain period, okay? If you throw an exception, the message will go back on the queue after a certain period of time, right? So you need to make sure that how you code this is semi-resilient. Now, I say semi because sometimes you actually want the message to go back on the queue. So for example, if for some reason I pull down the web job, like stop it running, I actually want all of those the messages that I was halfway through processing to go back on the queue. You've got to be careful of the poison pill scenario. So basically, if you have a message that always crashes your function, it will go onto the queue again, and again until you fix up your code, right? So you do need to be aware that is an inherent problem with queues, and you do need to think about it up front to make sure you handle it. Okay, I'm going to take that message. I'm basically just going to use a JSON deserializer to give me the new project object. Now, actually, the new project object is not just a project. It actually has my account ID and the access token in it, but it's what I need to access or to update the database and then to notify the user back out. I'm also pulling here the database connection string that I'm going to use. So again, it's just pulling it out of app settings so that I can then go and create a data context myself. Let me just do that. So this code is basically using or spinning up an instance of my data context. Okay, again, Entity Framework core, just easy read write. Using the same code that I had before in my web controller to basically retrieve out the active account. The only difference here is that I'm actually also priming up an instance of the graph service, because now, in addition to creating the project, I'm actually going to go and interrogate using the Microsoft Graph Service my email. Okay, so I'm going to use that to pull back all of the email that basically match. This graph service is actually a service sitting in my service code that basically wraps the graph and will do repetitive calls, etc., until it finds all those emails. So now I'm going to actually go ahead and create my project in the database. I'm then going to go ahead and retrieve emails from my graph service, which I just mentioned I was going to do. And you can see here I'm basically passing in the filter as a search parameter into there. And then finally, I'm going to go ahead and save all of those those emails to my database. So I've got a persistent caching of those emails. Okay, and so we've done all of the server-side work to basically say, okay, I've got this cache of emails. The only thing that's left to do is actually to notify back out to the user to say, hey, job done, project's created, those emails created. You can actually go and ahead and use those. So to do that, two things. Firstly, I need to write some server code to basically notify the user. And on the client side, I need to make sure that my application is set up in a way that's actually going to retrieve those notifications. So let me spin over to my application. And in the main page, once it's finished loading, I'm going to, in fact, I need to wait not just until it finishes loading, I need to actually wait until it's finished validating or verifying the current user. So once I've signed in, basically. And that's what this authenticated method or event here does. So on my view model, I've got an event that just gets raised when the user has been authenticated. And I'm just going to use that to register for notifications. Oh, let's try that again. Delete that and then register for notifications. So this is just another method call. You'll see here that I'm actually passing in the email account that was actually that was signed in, authenticated by. I'm then going to go ahead and write the code to actually register or create a push notification channel, as in the Windows world is what we call it. And then I use the push notification hub classes to basically register with the push notification hub. And the thing to call out here is that, okay, so we're passing in the channel URI. Okay, so you can think of that as the identifier of the app running on a specific device. It's got nothing to do with the user. It's really got to do with the app, a particular app running on a particular device, and identifying that. But I am going to pass in the account ID. Okay, so essentially what this is being passed in as a tag. And so from the server side, what I'm going to do is basically I'm going to send out basically a blast email, and I'm going to, a blast notification and say, send a notification to everyone or every registration or every channel that's been registered for this particular tag. Now, at that point, the server doesn't know what that tag correlates, or the notification hub doesn't know what that tag correlates to. It's just a string, right? So it goes through all of its registrations and looks for clients that have been registered for that particular tag. Now, in this case, the tag does correlate to an account ID. So on the client side, I'm registering using a tag that's set to an account ID. And on the server side, when I go to send the messages, I'm going to say, send a message to the tag that correlates to this particular account ID. So the only thing I'm left to do here is, so you see that this code, this registration code happens basically after I've authenticated, and you actually see that we will actually get a dialog popping up saying registration is successful. The last thing to do is, you can see the build error here, is that I've actually got to have a handler for what happens when I actually receive a notification. A couple of things here. Firstly, I've got args.cancel equals true. Okay. The reason that's there is because if I don't set that to true, the user's going to get this build-up of notifications in the action center. By setting that to true, it's basically saying, hey, I've actually handled this notification. Don't let it propagate all the way through to the notification center. Of course, if my application is not running, this code won't execute, in which case it's going to end up in the notification center anyhow. So the user can still click on that, launch the app, etc. So that's kind of the right user experience. You know, if I'm not in the app, user gets notified. If I am in the app, user doesn't get notified and the app handles it. And what we're going to do here is basically when that comes back as true, we're just going to repopulate the list of projects for the current account. Okay, if I go ahead and run it now, it's going to fail because I have to come back to my server and actually send out that notification. So you can see here, send notification, we're sending it out with the account, which is basically, let me just drill into that code. You'll see that I'm actually creating a notification hub connection string. I'm actually generating the toast notification to send, and then down here, you'll see that I'm actually sending the notification to a tag that correlates to the account ID. Sounds good to me. Let's go and see if that's actually going to run for us. Taking that as a not, given that it just fell over. Let's just try that again. I'm not quite sure what happened to my Windows app. Right. Okay, so that's the round trip to authenticate. So, okay, so registration is successful, so we've registered for notifications. And just to make sure that I know that things are going to run properly, I'm actually going to jump back into my function and make sure I put an event breakpoint there. And I'm going to do the same in my code for my client app there, so that I know that the toast is actually received. There we go. All right, so let's go and create another project in here. We'll go save as project. So that's the client-side code, server-side code to post. And let me see if I can, while it's doing that, I might load the Storage Explorer and see whether my Storage Explorer comes up quicker than the function starts kicking off. Because you'll notice, particularly in debugging, there's actually a bit of a latency between when you write to the queue and when the function triggers. So just be aware that there is a little bit of extra latency there. And so if I drill down here, you should actually see that we have in the queue, we have our new project, and there's our message, right? So it's still sitting there. Let's see, and if we can kick our thing to see whether it's going to pick the function up. There we go. Okay, so essentially this is going to follow that same sequence. So it's going to deserialize, it's going to create the project, it's going to go and hunt for some emails, those are going to get saved to the database, and then it's going to send the notification out. So let's see if it can go ahead and do that. So it came back and says it succeeded. Okay, so it's actually sending the notification there. And voila, we have a push notification that's inbound, And what we should see on the user experience is that our project appeared. Pray to the demigods, they were thankful to us today. Okay, so let's switch back to the slides for a sec. Okay, so the flip side of this is data retrieval. So on the flip side, when in the traditional approach, the client app's going to retrieve data via a service. The service has got to go off and query that from the database, okay? And the first thing that you run into there is that the service goes, I want to return you 1,000 records, of which case I'm going to be here like 10 seconds trying to build up those 1,000 records, and then you're going to be there for another 30 seconds while they download. Okay, that's not a great experience. Okay, it puts a lot of effort, lot of pressure on your service, both to query the database and then to package it, and then probably to compress it as well, because you'll turn dynamic compression on because you're a mobile app guy and you want to be, you want to be really respectful across the wire, so you want everything compressed. And then the service goes, that's fine, but it's going to cost you. It's going to cost you in time and effort and CPU cycles. And the reality is that the client, a lot of the data calls that you're going to make to the client are going to be very repetitive. Repetitive in two senses. The first one is that as you make calls for a large data set, you're going to have to iterate over it in order to get the full data set. So you might get 100 records at a time, in which case you're going to be making 10 requests in order to get those 1,000, and the number goes up, obviously, the more records you have. But chances are you're also repetitive on the second case, where the user will probably go through various sections through the app, and then they'll go back to the beginning, and if you haven't coded it well, that initial request for the 1,000 records, you're going to make again, and go and get those 1,000 records just because you think that one of the records might have changed, okay? So there's definitely some optimization that you can have around that. Okay, same three problems around data connectivity. So if you're not online, you've got no data. If the service is not online, you've got no data. If your database is not online, you've got no data. Okay, any one of those three things could happen depending on what's actually happening on the server side with your application. Being in the cloud doesn't necessarily guarantee you 100% uptime, right? At a variety of different levels, right? So try and build your apps to be more resilient. Database load is based on queries, okay, and not very well optimized around those, okay? So it's very difficult to optimize your database and your, the server side. And even if you turn things like intelligent caching on, you only get so far in terms of doing it. And so you're somewhat limited by the query performance and your ability to cache it on the client side. So what I'm proposing is that in this particular scenario, and granted that these two scenarios that we're looking at now are just an example of what you can do to alleviate the pressure off your database backend. I'm not saying that you have to use these in every single scenario. But what we're going to do is our web job is, we've seen how a web job can actually used to save data, but we can also use it to periodically query the data and pre-cache data. Okay, so in this case, we're going to prepare blob data, and then we're going to make that blob data accessible via the CDN. Okay, and in doing that, we're going to make our data retrieval very quick. Okay. The way that you should be architecting this and designing it is that those blobs that you're downloading should be infinitely cacheable, right? So the thing about blob storage is, yes, you can put a no cache header on it, in which case nothing will cache it, and you can go and update it. Okay, that's not the intent behind blob storage. You're much better off putting an immutable object that never ever changes there. Now, where this becomes a problem is obviously if you've got a data set that grows over time, or that it's going to be added to and deleted to and updated, then you need to start to think about, okay, well, how do I then go and modify that blob? Okay, you don't. You leave it as it was. What you then do is you create a change set based on the original. And then you need to think about, okay, but hang on, my change set's going to grow over time, so you need some resilient points where you basically say, okay, well, if the client never got the original blob, then instead of getting that one, get this one, which is basically a condensed version of all of those updates. Okay, so you can start to think about some scenarios there. But the important thing is that your blob that you've created, that's now published out via the CDN, is the same blob that you published originally, right? It hasn't changed, right? It's still super quick to download, and the more people that download it, the quicker it's going to get, and the more it will be cached in the CDN. So that's an advantage to us, okay? The database load, the queries are scheduled so that the load can be managed, because essentially, particularly for the scenario I'm giving here, is that I don't want it to be up to the minute accurate, right? The point of this is more of a data analysis, a research kind of tool to go back over a project and say, okay, what was the volume of email, and where were the issues associated with this project, right? It's a research tool. So and pretty much once the project is done, it's not going to vary that much, right? So the point is that I can have this running on a web job to periodically update that data set. It could be once a day, it could be twice a day, okay? But those are very, very schedulable, okay? And so we've got much more predictable load on our database. And of course, performance, because we're downloading from the CDN, okay? It's going to be super quick. And in fact, I can request that it's compressed, okay? And so all of a sudden, the amount of the wire becomes a lot quicker and a lot easier to deal with. And actually caching it on the client side is super easy because I don't need to worry about what relation format I'm going to use. I just save the cached blobs, right? I literally download a text file, save it to disk, okay? When I need to read it, I read it back up. No, you know, I might, depending on how big the data set is, I might want to think about, you know, archiving a summary in some sort of format just so that I can quickly access the index. There are some good use cases for doing that. But a lot of the time, we can just cache it pretty much as is. Okay, so let's just jump into the final part of this demo. It should be relatively quick. And rather than spinning up a separate web job that's going to do this, and bearing in mind what we want to do is basically take the email that we've just written to the database and publish it out in a format into blob storage that can be quickly downloaded. So rather than spinning up a separate, you know, timed web job, let me just come into our existing web job, and at the end of it, instead of, before we send out the notification, let's just come into here, I'm going to take these saved emails, and I'm just going to write them to blob storage. Okay, so let's just grab that. So that's going to save them up to blob storage, so you can see that I'm basically loading the storage service. I'm using an emails container. I'm basically just using the project, some permutation of the project to basically identify the blob. Now, this one at the moment doesn't evolve over time. Obviously, it's a very simple scenario. And of course, then we need to go onto the client side and change the way that we're accessing that content. So let's just go to our mail service. Hang on, let's actually go to our data retrieval, which is going to be in our project email view controller. Okay, so it's basically the view controller associated with actually looking at the content for a particular project. Let me just grab that code in there. Okay, so and this is calling into our retrieve project email service. Let's go into that. And let's go to the implementation of it. So this is all client-side code. Okay. And at the moment, we've got it basically calling an API called project email by ID. Okay, so basically passing off the project ID and getting back a series of email. Now, we want to switch that to basically use retrieve our blob. Okay, so it's simple as that. So we're basically retrieving a HTTP client. We're basically predefining what the blob URL is and pulling those down. Now, I would caution that there is a world of problems associated with this, namely the fact that there's no security around this at the moment, right? And if I'm publishing my email up there, then I probably want some form of security around there. There's a bunch of things that you can do. Blob storage does allow you to encrypt the content up there. Otherwise, you need to think about how you're going to self-encrypt things. Okay, so let's just go ahead and actually run this. Let me just double check the email controller is all set up as well. For those who are interested, populating the actual original email controller that I was going to call is as simple as just doing this. So it's basically just retrieving a list of emails from the service. We won't be calling that because we're going to run it up already connecting to blob service. But I just wanted to show you that this is what it was going to do the slow way. And now we're actually going to connect to blob storage directly to pull that down. Now, we will have to create a new project because the way I've written, obviously, the function at the moment does require that it caches the blob at the point where we're creating the project. So sign in again. We've registered. Let's go ahead and save this. So it's creating our project for us. posting to the queue. And again, if we refresh there, that's updated to a new message, okay? And hopefully in a second or two, we should see that pop out into our web job. The number of times I've sat here thinking, did I actually write to the queue or not? Because it takes longer than expected. And it takes a little longer than expected to go and query that, to run that. The notification comes out. And then when we come over here, then click on Demo 5, and the emails, like, notice how quick that was? It pulled it straight down for blob storage just by a simple HTTP request. Now, the only permutation I would suggest on there is the difference between calling it directly blob storage versus calling to the CDN is literally the URL that we're going to call there. So if I go to, where is it? My services, I can change this across to using, so that's the blob storage URL. If I change that to azureedge.net, okay, you'll find that that actually will go ahead and actually request it via the CDN. Okay, so it comes down to even quicker. Behind the scenes, if you're interested about how that's configured, essentially you go and create a CDN object within Azure. And it's made up of a series of endpoints, right? And you can see here that, and I click on that, the properties associated with that is basically just a routing. So it basically routes through to my domain behind the scenes. So you can see here that the endpoint host is mailmate test, azureedge.net, and then the origin host is basically my blob storage. Okay, so essentially it just takes the path and actually appends that to the blob storage URL. There are a few limitations on the CDN side of things. So obviously if you're using things like shared access tokens, there's a few things that you want to do to actually get that to work. And obviously if you're using custom domains for some of your blob storage, that stuff doesn't really work on the CDN either. Let's flip back to this for a second. And just to wrap up, so essentially when you're building stuff for the cloud, in order to get a success, not a fail, you need to architect for. And the interesting thing here is that I'm sure that the cloud architects in the room will go, nah, you should just be architecting for scale. And it's like, well, no. I mean, the whole point of doing this exercise is to make sure we have a better user experience. So architect for a better user experience and obviously scale. And then you just need to be aware of the bottlenecks and the costs. Okay, so depending on what things you build in Azure will determine what your costs are. And SQL's not a cheap option, never has been. And so if you can alleviate that or have a smaller instance of your SQL box there, one that's just responsible for housing data, then that's going to keep your costs down. So, and that's pretty much it. Let me just give you the mandatory slides. So session evaluation. Continue your Ignite path, and for most of you, that will be going to the party this evening. And then if you do need to get hold of me, there's my contact details, and I'll be around in the speaker lounge and this evening, etc. So feel free to come forward with questions. I'm happy to take them from the floor as well. Thank you very much.